Catus Maximus here. Going to do a quick teardown of this Harbor Freight EarthQuake EQ12 XT, the big half-inch drive impact wrench. If I can get the battery out of here. The batteries are always so tight on this tool. I'll tear down the battery and the charger. This is going to be more of a basic teardown. Just to give my impressions of the construction of this versus many other tools I've taken apart. There's certainly a lot of videos about this one. They do have a little rubber thing in the back of the battery contacts to help keep it from vibrating around, provide a little bit of tension. I do appreciate that. Anyway, we have T15 screws and then T20 screws on the front of the gear case. Let me go ahead and pull those out. Alright, those screws are surprisingly tight. Let's do a comparison. All the body screws are the same size, which is nice and easy to keep track of, and all the gearbox screws are their own same size here, if I can get this in the right position. This is interesting. They're using shoulder bolts, so this has a wider diameter up here on the top of the bolt than it does down here on these screws, so that helps maintain more precise alignment of the gearbox, although we'll see, I believe there's also alignment pegs in there, but that's something nice to see. That just helps hold the gearbox a little more securely. These are a very deep groove. They also really undersized the holes in the body. These were pretty tight, and I was actually pretty surprised. Same thing with the clamshell screws. These are known as plastite screws. These are screws that have one set of really deep threads and another set of more shallow threads. Tapcons, concrete screws, are similar to this. It means that's a little bit more important when you're putting them in to try to feel so it goes back in just the same way. Otherwise, what happens is you pull although you wouldn't take this apart very often at all, if you try to make sure that they go into the same deep and shallow grooves that they came out in, it'll provide a more secure hold than having it kind of cut new threads in there. As soon as we do that, we'll just peel apart the clamshell. Just rock it back and forth. That's usually all it takes, just a little bit of wriggling. And there's our clamshell. And just like many of the other videos, it's actually surprising how heavy duty this is. TPR, so it has the rubber overmold, lots of stake-on points, and just a whole lot of ribbing. It's actually pretty surprising. You know, this looks like it may actually take a couple of drops from some substantial heights. Here's where things get a little bit more interesting compared to the earlier ones, which had the silver gearbox. This is a newer one with the black gearbox. So I don't remember in the videos, the older ones, they having this fiberglass high temperature additional insulation put over the negative of the black wire. I wonder if that's something in relation to the electric brake mechanism. We can see that we do have a rubber sealed ball bearing in the back there, which is nice. Definitely nice to see. It's actually in its own little cavity, so when the two clamshells come together, they do provide some dust protection. This little lip, so it not only is it a rubber sealed bearing, it's not likely for grit to even get into that space in the first place. And then we have our fan, of course, our permanent magnet motor. We'll pull that out in a second. Let's get this gearbox out. One thing I should mention down here in the connectors, we do see 4 wires. So this is at least going to do under voltage protection. It's going to do temperature protection, and then it has a little battery ID wire. I think that's to let it know if you're using like a short 2 amp or a tall 4 amp battery to limit the current. In other teardowns, all the electronics are integrated right into the switch, and then the copper heat sinks just for the main switching transistor. Let me go ahead and pull the gearbox out, or get this whole mess out. There is a nice touch, even though the brushes are actually soldered. You know, Harbor Freight doesn't sell parts, but the way this would be designed, and they have these nice, easy screw-down terminals, which are very secure. And it's also nice that they, right where they spot welded the conductors, they put just a little bit of glue just to help relieve strain. Is you would just buy this brush card, and it would come with the brushes in it. And the reason I think it's kind of interesting is because if we can get this camera to cooperate here. Come on now, I don't know why this camera doesn't cooperate sometimes. We can see that they put little notches on the top of the brush guide specifically so you can pick up the spring and then set it right there so you don't have tension on the brushes. Certainly makes maintenance quite a bit easier. Now if we take a quick peek at our rare earth magnet motor, definitely some strong magnets in there. There it is. Doesn't look like the highest quality coating. It is, it looks like a light nickel coating, but we can see it's a real basic coating on those magnets. It doesn't have like a real nice, shiny, super thick nickel coating on there. Then we have our motor, which is drill balanced. Quite a bit of imbalance on that side. You can see quite a few drill marks. Nothing on that side. And very large windings. It's only a 20-volt motor, but it's a DC motor, and they're going to run a ton of amps to get you the kind of power that it really needs to put out. Durofix. Look at that. So now we have an idea. Durofix has been making cheesy tools for a long time, but that's interesting that Durofix would be the main brand of the contract manufacturer. So that's what this is a Durofix tool. Interesting. This is, it's engineered pretty well. There's some pretty thick gear teeth there, only a 5-tooth or really small arbor. But one thing we can tell is that the plate thickness on this motor, you can see right there, just as the terminals or the commutator just isn't very thick. This is not designed to ever have the brushes replaced. When the brushes wear out, it'll pretty much wear right through this plate. And so you replace the brushes and this center part at the same time, which is a little bit of a shame. It's like, it works and it's a decent tool, but, designing it to where you have to replace the armature and the brush, probably they do that because the bearings go out and it's so difficult to replace them and not really as cost effective. So they just sell you the whole rotating mass of the motor and the brush card when you replace the motors in these. But it's a wasteful process. You should put in thicker commutator bars so that, it'll last. A standard professional grade quarter brush tool, a Milwaukee drill or something like that, is rated for around 1,000 hours of total use, 3 to 5 sets of brushes. So it's disappointing to see what they've done here. Even though it's, made pretty well, it still has disposable aspects to it. So let's take a look at this gearbox here. Did want to mention these key marks. Those integrate into these little bosses right here. And of course, that's what prevents this from spinning around in the tool instead of the actual armature spinning. Well, there's indeed 4 integrated alignment pins. So this gearbox is going to be very well aligned. And then it uses the additional shoulder bolts. So that's pretty good. They're not press fit. 3 of them just fell out when I turned it this way, and one of them's still in there. Usually when I take apart these impact wrenches, I'll push down on the anvil. That way you can lift everything out, usually as one nice assembly, just like so. Not a lot of grease in this one. I see this on a lot of impact wrenches. There's an undercut in there just for like an O-ring, and it seems many times they just decide they don't need it, or maybe it dries out and gets bunched up in there. But I've seen that. I have these Milwaukees, and it's the same thing. There's an undercut, which looks like it's just enough depth, the right depth for an O-ring, but it just isn't in there. This gearbox is rectangular, so it goes this way or this way. It doesn't matter, which makes it pretty easy. And most impact wrenches are like this. They'll have the aluminum gear case, and then they'll have the steel front end here just to support all the loads. One thing that is interesting already is that they indeed are using a needle thrust bearing here, where the anvil is riding, if I can get this off, pretty tight. And I did notice this about the impact wrench. It has very little end play. Almost all impact drivers, impact wrenches have quite a bit of end play just so everything can spin freely. They have a needle bearing up there to take these frontal thrust loads, and it's actually pretty nice because then they can make the whole assembly be much, much tighter. And we can see down in there's a ball bearing. I believe that's loose because on one of the teardowns it stayed in the tip of this, and that's another nice aspect. So when you're putting pressure on this, the tip of this shaft is riding right on a ball bearing point, further increasing the ability to deliver power, more efficiently delivering power. One thing that is unique is that this mechanism here, where it's a spinning weight that climbs over the top of here, you can see the scrape marks, and then drops back down and then hits these dogs and delivers the impact, or the hammer, is almost always square. But on this one, they're rounded. And I think that may be just to release some of the stress, to tell you the truth. I think that's a bit interesting. We can see the interesting shape inside here versus these dogs just being absolutely straight. And I think that's just so it modifies how the force is delivered, maybe makes these dogs last a little bit longer. Now, speaking of the grease, they just put a little bit, it seems right there. If we pull out the whole impact mechanism, we have the aluminum back case. Pretty large bearing. Of course, it's inside the unit, so they don't, put seals on it. This is a pretty heavy-duty spring, and usually on these impacts, and it's something very few people talk about or do in the videos, because I use a puller to press on this to pull this whole weight back. Then you use a magnet to draw out those two bearings, and you release the puller, and that's how you can disassemble the hammer mechanism. But on some impacts, or almost all of them, there'll actually be either a ball or a radial needle bearing like this that's actually inside the weight, so that the hammer can't deal with all the friction of the spring. So there's going to be a ball bearing. Like on Milwaukee's and those, they put the bearing on the back here, so that the spring itself is also part of the impacting mass. We can see no bearing there, so which means the bearing is going to be on the inside of the weight here. These don't work if they don't have that bearing. It just, all the friction from the spring against just the raw steel, this just would not make a tenable impact. So they all have those. But unfortunately, they don't have it on the back. And it's a little disappointing, because they could actually make a hammer just a little bit harder. You'd have to source a special bearing, because it's going to be set up for this diameter and on this taper to keep it. So you'd have to get a completely different one. We can see that they have the whole mass going down just where there's just enough space for this hammer to draw back properly. So they're putting just as much mass as possible. Another nice thing is we can see 1, 2, 3 gears. For the longest time, it was corded or cordless. It was just 2-gear transmissions. And it seems in the last 5 or 10 years, there's been more and more manufacturers going with triple gear transmissions. It's really just statistics saying that, guess what? Unless your gears are really wide, they are going to wear out before the anvil breaks more often than not. So they started adding 3 gears. It makes it a more balanced setup than them being just 2 gears. And of course, reduces wear. So I think that's not too shabby at all. And then, oh wow, that is one yucky, greasy mess. We can see that there is a paper thin little gaskets, which is good. And the gear, the ring gear teeth in here are actually steel. This is a steel ring gear that's been press fit in the aluminum housing. Some of the other reviewers didn't quite mention that, but that is indeed, those are not aluminum teeth in there. That is a steel ring just pressed in. And that's basically the mechanical teardown. So I'm going to go ahead and toss this back together, and then we'll get into the electronics. Here we are with the battery. I already got the screws out. Just pull them out and then just slowly work, because the terminals are going to be held pretty stiffly in the top portion. Here's the whole top portion with the clips and then all the dividers. We can see that this is nylon glass fiber, 30% on the outer, or at least on the upper portion. And then this is the entire battery pack. And we can see that it isn't balanced, because we have just 2 extra thick primary power terminals, the thermal terminal and the ID terminal. So this whole top board just isn't physically capable of balancing. And what do we see here in this battery pack? We see these little metal tabs with holes in them. Those are solder points. There's even little tracks in the overmolding for the balance wires to actually be routed. There's the other tab, and there's one right there. And so this battery, the whole cartridge of the battery is capable of balance charging, but the rest of it isn't. So they just use these little Zener diodes, which are like pressure valves for electricity. So if they only allow electricity through if it's a certain voltage. So as the voltage drops, say maybe the cells drop to just below 4 volts, and that's a 4-volt Zener diode, it won't let voltage through, and that LED will start to go dim and then dark. And then this one may be like 3.8, and this one may be like 3.6 or something along those lines. Oh, and just to show to people, surprisingly enough, I mean, well, not really surprising. I mean, it's just surprising that they'd use a balanced battery pack and just chintz out on just a few circuits. But if we touch this terminal here, we can see we get 11.6 volts. We touch that terminal there, we get 3.8 volts. and we'll get the other 2 voltages off the terminals on this side. I'll do this. I'm not going to get to that one because it's right next to that terminal. I don't want to short it out. On that terminal, we get 15.47 volts. So fully balanced, capable battery cartridge in there. They just chinsed out. So obviously you could maybe order online, do modifications, but it's just cheeseball. They really didn't save that much money, and it could potentially even be a fire hazard in the most extreme circumstances, just because they're relying so much now on the thermal sensor in this battery pack in case one of the cells gets so inverted or is just so out of balance that it either overheats during charging, or lithium-ion cells, oddly enough, will also catch fire when they get way too low, if they get discharged down to nothing. And they're just relying on that thermal sensor to cut it off. And to not neglect the charger. I just do those hard cuts because it makes it more expedient. And the other reviews had shown this. They skimped on a bunch of components. This filtering on the input stage isn't to filter noise, because for this switching power supply, it's because the way it switches, it's just turning on and off, and it's like plugging in a motor, just unplugging and plugging it a whole bunch of times. That's why switching power supplies make so much noise. It's also efficient because they switch at much higher frequencies than, say, 50 or 60 hertz, and so they can use smaller transformers. But you have to use all this electronics to chop it up and then rebuild it in the DC on the other side. This is to reduce the amount of noise that this would be putting back into your power circuit. And so that's a little bit cheesy. We can see a couple of empty connectors here. It is indeed only 4 wires for the charger. So we have positive, negative, the ID, and a temperature wire. These other 2 connectors are 4 wires. This charging board may either have the ability to do balance charging through those 4 extra connectors. One of the connectors may be doing a midpoint balance, and the other one might be for a fan, but who exactly knows. So anyway, that's the end of this teardown video. Just want to do my take on it, and I do agree with many other commenters on my review of this, is that Harbor Freight, on what they've done is the price of this is now getting within $100 of getting a Milwaukee or DeWalt or some other respected brand that has a much better warranty than 90 days. I mean, hell, for the and then there are various sales and deals that you can hunt down. And so that's really the deal with this EarthQuake being $270 retail. I mean, I paid less than half of that because of the Harbor Freight discount shelf, but the chintz out where they did on the charger and battery is an issue. What they should really be doing is selling this for $300 and basically offering the same power and a good battery and charger balance technology. People aren't going to have a big issue with it only having a 4-pole brush motor versus having a brushless motor. If you charge 25-30% less for a tool that's almost as good a quality, then you do have a market for that. Otherwise, anybody who, it just is unfortunately disappointing. Otherwise, I'd say actually, if you're going to use this kind of charger and thing, make it a little less powerful, lightweight, and charge $200 for the thing or something. Make it either Harbor Freight cheap, or make it a good product that is competitive. And I think this tool is, but man, I'm waiting, since these only been in the market for a couple of years, I'm waiting, for the next year or two to start seeing a bunch of reviews and a bunch of people talking about how the battery just up and quit, or started bulging on them, or overheated and almost caught fire or something like that. Which is a shame, because the mechanics of this are actually built well enough for it to last the single set of brushes, which is obviously also a little bit of a disappointment that, if they even had parts, you'd have to replace the whole brush card and the armature at the same time. And that just makes it just a little it's too expensive to be essentially disposable like that. Anyway, I really appreciate everybody watching and subscribing. If you haven't subscribed, please do. Until next time, Catus Maximus out.